Are there any irreducibly complex cellular or biochemical molecular systems? And the answer is, yeah, they're all over the place. You can't turn a page of a biochemistry textbook without running into such systems. For example, here's the flagellum that Steve talked about. This is a drawing of the flagellum from a biochemistry textbook by Vogt and Vogt, which is used widely in universities across the United States. And as he said, this is quite literally an outboard motor that bacteria use to swim. This is the part here which acts as the rotor. It's spun around and around and around in a rotary fashion and pushes against the water and therefore pushes the bacterium forward. It's attached to the drive shaft by something called the hook region, which acts as a universal joint, allowing the rotary motion of the drive shaft to be transmitted to the propeller. The drive shaft is attached to a motor which uses a flow of acid from the outside of the cell to the inside of the cell to power the turning of it, just like water flowing over a dam powers the turning of a turbine. The drive shaft has to poke up through the bacterial membrane, and so some parts act as bushing material to allow that to occur without leakage. And I know this looks complicated, but let me assure you, this is just a little cartoon view of the bacterial flagellum. This is much more complicated than this illustration appears. For example, just as an example, the parts of the flagellum are not these nice little symmetrical geometric lozenge shapes and discs and so on. These are actually constituted of very complicated molecular entities themselves, proteins, which have to self-assemble and build this rather complex structure from the inside out. Nonetheless, I think this gives you this is sufficient to get across the idea that, like a mousetrap, the flagellum is irreducibly complex. If it weren't for the hook, or the drive shaft, or the motor, or the propeller, you would not have a flagellum that spun half as fast as it used to, or quarter as fast as it used to. You would have a broken flagellum. Or much more likely, you would have no flagellum, because the cell, it turns out, has sensitive feedback mechanisms to tell it when the construction of this machine is going well or not well, and it will shut off construction if it senses that it's not going well in order to save energy. Now, I like to show folks this illustration of the flagellum because most people, when they look at this, quickly realize that this is a machine. This is not like a machine. It is not analogous to a machine. This is a real machine. And thinking about this might let us kind of figure out how we could explain where it came from. Now, let's see, where am I? Okay. Now, as Steve said, the science in the past 50 years has discovered, much to our surprise, that the cell is based on machinery. It's like if anybody's watched Star Trek and knows about the Borg, who are these kind of half-human, half-machine-like entities. They run on nanotechnology. Well, it turns out we do too. In that sense, we are the Borg. We run on nanomachines. For example, here's an issue of the science journal Cell, a special issue on molecular machines. And if you turn the page and you look at the table of contents of this journal, you find papers with titles such as "The Cell as a Collection of Protein Machines," "Polymerases and the Replosome, Machines Within Machines," "Mechanical Devices of the Spliceosome, Motors, Clocks, Springs, and Things." So all of life, we now know, is based on these horrendously complex, elegant, sophisticated machines. Now, I wrote a book a while back, as Steve mentioned, arguing that Darwin's theory could not account for this machinery in the cell. It turns out that's not all that controversial. There are a number of scientists besides myself who agree that Darwin's theory is not up to explaining such discoveries. People like Stuart Kaufman of the University of Calgary and Lynn Margulis at the University of Massachusetts and so on. And they have their own ideas about what might replace Darwin's theory here. But my difference with them is that I've written that the best explanation for these things is that they were designed, purposely designed by an intelligent agent. And a lot of my critics have said, and I guess I should tell you that I do have some critics. Some of my critics have said, well, that Behe fellow, he's a known Christian. He has been seen entering and leaving churches. And therefore, this idea of intelligent design is a religious idea. It is not a scientific one. And that I'm letting my religious convictions interfere with my scientific work.